So there were two statements of the fundamental theorem of calculus. Version 1, version 2, part A, part B, but they're all part of the fundamental theorem of calculus. The first one that we looked at was that the integral of the derivative of f is what? Wait, did I say that right? The integral of f prime is f of x, and then if there are limits to consider, top minus bottom. That was the sort of the first formulation of the fundamental theorem of calculus. The antiderivative of the derivative gets you back to the original. The second way to put it, the second version of it, is that if we take the derivative of an integral of f of x dx, this one's a little bit trickier because we need to put a limit. We need to put some limits on there that aren't just numbers, because if they were just numbers, then all of that would just be a number and its derivative would be 0. So I need, usually we put like g and h up there. I don't know that it matters which one goes where. G of x, h of x. So this one starts to look fancier, but again, the big picture is I've got the derivative of an antiderivative. Those cancel each other out, so I'm back to f, but I have to plug in g of x. And what else do I have to do? So plug in the top, minus plug in the bottom, but before I move on to minus plug in the bottom, chain rule. So plug in the top times derivative of the top minus plug in the bottom times derivative of the bottom. So again, the whole unit is derivatives and antiderivatives cancel each other out. Well, of course they do. But plug in the top minus plug in the bottom. If you're taking a derivative, don't forget about chain rule. Now, how we actually evaluate that integral is sometimes with an antiderivative, like an antiderivative by hand. Sometimes with a calculator, like let the calculator do the work. And then sometimes we use area under the curve to evaluate those antiderivatives or integrals. The test is all no calculator, so obviously you won't have to do the calculator one. But some questions are antiderivative questions. Some questions are area questions. Some, I guess, I could just say are given. Like, let's do number 1. If f of 1 is 12, f prime is continuous, and the antiderivative of the derivative of f is 17, find f of 4. Okay, so this problem, I feel like it almost gives me too much information. The x's are 1 and 4. The integral from 1 to 4 of f prime. I know that's 17, but it's also the antiderivative of the derivative cancels each other out. F of 4 minus f of 1. And this is supposed to be the easiest one on the page, because this side they told me is 17. F of 4 I'm looking for, and f of 1 is 12. So if I move 12 over, I get 29. I wonder if we should do number 2. So that thing is equal to 17. We want to find what this little piece of it is. let's break this thing up a little bit here. So 2 integral from 2 to 5 f of x dx, that's what we're looking for, plus, now I'm going to apply that integral to 3, and all of that is equal to 17. And again, I'm trying to find this thing. Are you okay with what we did so far? Just kind of expanded that problem they gave us to isolate the thing that we're looking for. Okay, how about the integral from 2 to 5 of 3? Do you know what that is? There's a quick way and a long way. It's not 0, because the antiderivative, maybe that's what you're thinking, like the derivative of 3 would be 0, but the antiderivative of 3 is 3x. Plug in 5 minus plug in 2. So that would be 3 times 5 minus 3 times 2. 15 minus 6 is 9. There is a slightly different way to get that. I guess nobody thought of it the other way. The other way is, like you thought of it as the antiderivative way, which is fine. That gives us the right answer. If we think of it the area way, then it's the area under 3, 1, 2, 3, between 2 and 5, and so 3 times 3 is 9. So that's one of those few spots where you could do it either way. You could either think of it in terms of area, or you could think of it in terms of antiderivative, but you get 9 either way. So I've got 2 times this chunk of stuff that I'm looking for, plus 9 equals 17. So subtract 9, you get 8. There's where 8 comes from. But then divide by 2 and get 4. I feel like it's pretty rare where you can do the antiderivative method or the area method, because usually you don't know enough to do both of those. Usually you have enough information to do one of them. Number 3, right? Let's just keep going for a minute here. Table below gives the person's cholesterol at different times during a 10-week treatment period using a trapezoidal sum. Okay, so that's base times average height with 3 subintervals. Okay, that makes sense because I've got 4 data points, which makes 3 intervals. Approximate the average level of cholesterol. Okay, this is frequently missed on the test, because some people see trapezoidal sum, they know how to do trapezoidal sum, so they just do the trapezoidal sum of that, and well, that's not even one of the answers. I'm surprised it's not. But the trapezoidal sum gives us the area under the curve. Average value is not area under the curve. Average value is 1 over b minus a, integral from a to b of the function. Again, that definitely have to know that. The trapezoidal thing comes in. Use the trapezoidal sum. The trapezoidal sum we can use to approximate that part of it. So I still got the 1 over 10 out front, because that's the full width. And then we'll approximate the area with trapezoids. So 2 times 210 plus 200 over 2 plus 4 200 plus 190 over 2 plus 4, 190 plus 180 over 2. Let's use a calculator only when indicated. Oh, this isn't too bad. If I really had to do this without a calculator. The 2's would cancel, dividing everybody by 10. So 21 plus 20 plus, let's see, that reduces to 2. The zeros cancel out of there. So that'd be 40 plus 38. A lot of math in my head here. And then on the last one, 4 and 2 cancel the 2. The zeros cancel because we're dividing by 10. So 38 plus 36. So whatever all those add up to, that's still mildly annoying. $41, 81, 81 and 38 make 119. Those two combine to make 74, so 193. Annoying that that's not a calculator problem. There will be one like that on the test where it says use, I don't know if it's trapezoid, but a right sum or left sum. And the trouble is students forget about the 1/10 thing. They forget about you're finding the average value. They see trapezoid sum and they just immediately jump to, there's my trapezoid sum, and I guess their answer for that one would have been 1,930 because they forget to do the 1 over b minus a thing. So be careful. Read the question. Make sure you understand what you're going for. Average value using the trapezoid sum. So don't just do the trapezoid sum. Use the trapezoid sum in the pursuit of the average value. Just keep going. Number 4. Look. What level is G decreasing? Okay, enough of me talking. How do I know, Seth, when G is decreasing? What would I be looking for?
For F prime negative.
Good. Now, I don't care about this junk right yet. I want to know where G prime is negative. Okay, so I need to take a derivative of G to get G prime. So G prime is the derivative of all of this. So perhaps that looks terrible. Rewrite all that stuff. But what's going on here? Why is this suddenly a little easier than maybe we thought? What's the trick here, McKenna?
They cross like they cancel each other.
Yeah, those two things kind of cancel each other out because it's the derivative of the antiderivative. Plug in the top minus plug in the bottom. Don't forget the chain rule. So x cubed minus x squared minus 6x over the square root of x squared plus 7. Chain rule is times 1. And what happens when I plug in negative 1? Yeah, well, eventually I get 0, right? I can plug it in and get a bunch of stuff, but the derivative of that would be 0. So times 1 minus a whole bunch of stuff times 0. Because the chain rule off of that would give me 0. Okay, so this looked terrible. It turns out to be not quite as bad. So I just really want to know where this thing is negative. That denominator looks awful, but there's something nice about the denominator. I'm thinking number line and then test values. So I need the zeros at the top and the zeros at the bottom. But that bottom is never going to be 0. X squared plus 7, that's never going to be 0, so I don't really even have to worry about it. I'm only worried about where the top is 0. So 0, -2, and 3, which is good news. I start peeking ahead at my answers, and those values are all there. So let's just plug in a point and see what we get. I'm going to plug in 1. G prime of 1 is 1 minus 1 minus 6 over the square root of 8. And again, I don't really care about values. I just care about positives and negatives. So the top is negative. The bottom is positive. So the answer there is negative. What allows me to use the alternating rule on this one? Why do I not need to check another interval? How do I know it alternates? Or when would it not alternate? Uh-oh, because if you don't know this, you got to check all those intervals to sort of convince yourself that it alternates. Seth, you were trying to whisper something?
Double zero or something.
Yes, if there's a double root, it doesn't alternate. But I don't have any double roots. All these are single roots, so I can trust the alternating rule on this one. As always, if you're not sure, and if you have time, you can check more than one to make sure. So I wanted G prime to be negative. That's when G is decreasing. So that is there. Let's see if that's an answer choice. Less than -2 and 0 to 3. There's a lot of work in that one little problem. Five and 6 are pretty similar. If you integrate the rate, you get the change in the amount. Amount B minus amount A. So 5 and 6, that's both of those. And they're both calculators. We'll skip over that. You would integrate the rate, and you would use, it's sort of like the very first one, t equals 0, t equals 10, so you'd probably go 0 to 10. On number 6, integrate the rate. Pump is started, so that's t equals 0. 1 hour later, so you're going to go 0 to 1. Equals the amount at 1 minus the amount at 0. Usually they give you one of those. 1,000 liters when you started. This one would be tricky because I have to be careful here. Pump out. So you're going to be careful with the signs on this one. If we're pumping out, then that means the amount's going to go down. So as long as you keep that in mind. In fact, if we started at 1,000, if we're pumping water out, then I can throw out answer B, because that's like we pumped out water and somehow ended up with 258 more gallons. In fact, without even working the problem, I bet 258 is the amount pumped out. That's that integral. But that's not our answer. That's how much left. So our answer is 741. That's my guess without even working the problem. Number 7, number 8, number 9. Ooh. Oof, 9 and 10. Pre-cal stuff. 11 is a review question. Thinking of time here. So pick 1 or 2 from 7 through 11. Which one? Number 10. Cotangent squared plus 1. I'm pretty sure that's one of those identities. I don't know which one because sine squared plus cosine squared is 1. If I want cotangent to show up, I need to divide by sine. So 1 plus cotangent squared equals cosecant squared. So the integral of cosecant squared I know there's somebody who has a derivative of secant squared. Right? Who has a derivative of secant squared? Tangent. Back up to the one we know. Which means, who has a derivative of cosecant squared? Negative cotangent. Alright, so like I don't have all of the trig things memorized. I have the important stuff memorized. No offense to cotangent squared and cosecant squared. Like, that's the things that I have memorized. I can figure out the rest. So this is negative cotangent of x from pi over 3 to pi over 2. Negative cotangent pi over 2 minus cotangent pi over 3. Cotangent, goodness. Pi over 2 is there. Cotangent is x over y. So that's 0. Yeah, x over y, x over y. Pi over 3. I could do x over y, but I remember that the tangent of pi over 3 is root 3, and if I flip it over, I get root 3 over 3. This is a trig question more than a calculus question. 2 negatives make a positive, root 3 over 3. That's a parenthesis, sorry. There we go.
Why did we divide it by sine division?
Because this is the only identity that I memorize. I know that if I want to get the others, I either divide by sine squared or by cosine squared to get either this or the other one is tan squared plus 1 equals secant squared. But I don't really have those memorized. I have this one memorized, and I know how to get to the other two. And I knew I needed it because I recognized squared and a plus 1. That made me think that this was one of these identities. I was couldn't remember exactly which one it was.
Why'd you put the negative like outside of the parentheses?
This negative, like I just wanted to, I kind of wanted to not mess with it really until the very end. I could have distributed it and then I'd have had negative plus. I'm peeking ahead at number 11, and one of those answers I'm pretty sure I can rule out right away. Which one are you throwing out? Why C? I agree. What do we call that? Yes, there needs to be more stuff. What's the name of the thing that puts more stuff on the end? Chain rule. Like somebody didn't do the chain rule on letter C. So I got to do a little more work to figure it out, but somebody completely forgot the chain rule for C. Let's see. 3 out front. Decrease the power by 1. We've got a lot of chain rules here. The derivative of secant is... What's the derivative of secant? Secant tangent. Make sure you keep the 4x squared in there. Secant 4x squared, tangent 4x squared. And then the derivative of 4x squared, while we're having fun with the chain rule, would be 8x. So 3 times 8 is 24. Okay, got that. Secant squared times secant, that's where secant cubed comes from. There's the x, there's the tangent. So let's answer D. I think we should probably look at number 9 though, because I don't, right, there's 2 ways to work integral problems. There's antiderivatives and area. I don't know what the antiderivative is, so I better know what the area is. And if I want to do the area, I have to know what the graph looks like. This, like, you just need to know this, like, add this to your parent function bank of knowledge, what that graph looks like. Because they like to ask questions about that graph. Limits, derivatives, integrals. There's that graph. You just got to know what that graph looks like. So the area from -1 to 2 of that graph would be, this area is -1, this area is 2, so what? So it's not a hard question if you know what the graph looks like. Got to know what that graph looks like. Guaranteed they'll ask something about that graph. It's good for limit questions because you can do limit from the left or the right, things like that. Oh, let's see. Which is equivalent to 12's one where you could go the long way or you could go the short way. The long way would be the antiderivative way. The short way would be the area way. So the graph of sine looks like this, but from 0 to pi means we want the area under that first wave there, that area. So the question is, let's see, let's draw a cosine graph. Cosine starts at the top. It does that. So from negative pi over 2 to pi over 2, there's our answer. That's the same area. All right, 0 to, that's this one. 0 to pi would be that area. That should be 0, because I bet those are the symmetry of that thing. Negative pi to 0, that's the same shape. What's wrong with answer C? That would be negative. So whatever that area is, this would be negative area. So that guy's out. And negative pi over 2 to pi over 2, that would be from there to there, that would be 0. So that's a question that I would do area method rather than antiderivative and plug it in, because that would take a while. Like, you could get there, but you'd have to evaluate all of those, plug in all of those things. This is supposed to be an area question to make your life easier. Let's see. 13 looks like antiderivative of f prime gets you back to f. This looks like using area to do an antiderivative. 15. H is the area. What's H prime equal to? Here's the big point of number 15. What's the derivative of H equal to? The slope of H, that's fair, but I don't have anything with H, so that wouldn't help me. If I take the derivative of this guy, I would just get f. So H prime is f of x, which means the second derivative, because I'm looking over here at my answer choices. What's the second derivative of H equal to? F prime. Okay, so let's figure out all these pieces here. H of 6, that's the area from 0 to 6. I don't know what that is, but it's negative. Hopefully that's enough. H prime of 6 is f of 6. What's f of 6 equal to? 0. And H double prime of 6 is the slope of f at 6. What's that equal to? Positive. And that's all I need to know to put them in order. In fact, that one worked out pretty well, because negative, 0, positive, that is the right order. Answer choice A. We've seen that kind of question before we had to use this derivative of antiderivative stuff. $16 you can figure out. 17 is like a traditional, like by hand antiderivative. Nothing tricky about 17. That's just go through the pieces and take the antiderivative. Let's get through 18, and then I think we'll be all right for today. A bowl of soup is placed on the kitchen counter to cool. Temperature of the soup is given in the table above. Okay, so this is the temperature of the soup. Find the antiderivative from 0 to 12 of t prime. Okay. Oh, does anybody see what the trick is here? The antiderivative of a derivative gets me back to what? T of the top minus T of the bottom. So I thought this was going to be some Riemann sum, rectangles, trapezoids, left-hand rule, right-hand rule, but the antiderivative of a derivative gets me back to the original, and so this is really just asking 93 minus 105, would that be negative 12? So that turns out to be an easy question. Part B is sort of like Part A, using correct units. Explain the meaning of what we just found. So, Kenneth, how would you, in the context of this problem, we said this is negative 12 degrees F. What is that?
Just T.
Okay, it's T, but I need you to say more than that. Because there was no time that the temperature was negative 12. Maybe look back to this. So it is a temperature. Might help him out. What about the temperature, though? The change. That's the key word we're looking for there. It's the change in temperature. From 0 to 12 minutes. Because if you integrate a rate, you get the change in the amount. That's sort of another way of saying the antiderivative of a derivative gets you back to the original. Okay, so it changed by 12 degrees. Explain why there must be at least one value of C such that T prime of C equals negative 1. Must be at least one value. That means like either intermediate value theorem or extreme value theorem or mean value theorem. So there's one in the middle, or the slope equals slope. I think this is a slope equals slope problem because it asks for T prime equals negative 1. So I've got to figure out, this is where I've got to play the game of like which combination of these gives me a slope of negative 1. And again, I can use like all different combinations. So this one's not bad. Do you see, oh, I say that, where'd it go? Do you see a combination of values that would give me a slope of negative 1? Oh, there's two different ones. Which one do you see? 8 to 12 works, because that's 4 minutes and a change of 4. Or 0 to 12 works. That's probably what they were going for, because we just found negative 12 in 12 minutes. But I saw 8 to 12 first. On 8 to 12. Okay, let's see. MVT. Let's back up, because we have to say two things are true in order to use MVT. T is, do you remember what the two things are? Continuous and differentiable. And it told us it's differentiable. T is differentiable given, therefore continuous, therefore MVT applies. So now we can do on 8 to 12. MVT is algebra slope equals calculus slope. The calculus slope, that's That's t prime of c. So that's what we're aiming for. The algebra slope, 93 minus 97 over 12 minus 8 is negative 1. Thank you. Part T. This is like a throwback question here. Autumn average rate of change? How do we find that?
You take the top minus the bottom.
Wait. Top minus top over bottom minus?
Yeah.
What's the word that I'm usually associating with average rate of change? Algebra slope. Slope, but algebra slope, not a prime, not a derivative. So the algebra slope from 5 to 8. So 97 minus 99 over 8 minus 5. That's a safe stop. It didn't even ask for units. But degrees per minute. It changes 2 degrees in 3 minutes. Or goes down 2 degrees in 3 minutes. All right, that's a lot. We'll stop there. I'm going to stop there. Your assignment, Monday's assignment, is 22 to 31. Tomorrow I'll work some of 22 to 31. There's a couple of throwback questions in there. And then we'll be ready to test on block day.